In this video, we are going to talk about function notation and finding the value of a function. Let's look at function notation first. So in this video, I'm assuming that you know how to distinguish between a relation and a function. So you have to know that in order for a relation to be a function, it has to satisfy this one big rule, which is every input should have only one output. So, as long as that condition is satisfied, then we write this relationship using the function notation like so. Here, x is my independent variable, also called the argument. And this y equals f of x, this whole thing is my output or my dependent variable. So the way that a function can be visualized is that if there is an input that goes into the function model and the output comes out of this model. Now this function can be represented by any letter. Commonly we use f, but it can be g, it can be h, it can be anything. And the input can be any letter as well. Even though x is commonly used, it can be y, it can be z, it can be t. For example, if t is the input and this function model is represented by the letter g, then the output will be g of t. So what this g of t says is that it is not g multiplied with t. It just represents the fact that the output of this function is given by g of t, and this function receives t as its input, where what values does t have? T has anything that is in the domain of that function. So this is how we represent a function model. Now, assuming that we know what that is, and this is the notation that we use, we have to know that x is the input, f of x is the output. So the biggest set of all numbers that can be input into the function is called the domain, and the output of that function, which is all real numbers, is the range. Okay. So all the y values will be the range, all the x values is the domain. So now let's look at one function. So I'm going to use f of x notation here, and this function is represented by, let's say, this expression. So this is my function. My input is x, my output is f of x. Now, if the question asks you, find the values of f of 0, f of -1, f of 3, f of negative x, negative f of x, and then let's say it says f of a plus 1, and then it says f of x plus h. Okay. So the question is asking you, if this function model receives 0 as its input, what will be the output that this function is going to give? In order to do that, all we are doing is to evaluate f of 0, we go to the function, and wherever you see x in the function, you replace it with this input 0. So you have negative 0 squared plus 2 times 0 plus 3. So I want you to pay attention to substituting values. Wherever you see a negative sign, an exponent, it's always a good idea to substitute and use parentheses in your substitution. And another commonly made mistake is to write f of x equals and then say negative 0 squared plus 2 times 0 plus 3. That's not true. F of x is negative x squared plus 2x plus 3. We are evaluating f of 0, right? So simplify this. 0 squared is 0, 2 times 0 is 0. So this answer is 3. So your answer to, let me just put the answers here. Suppose if this was part A, you will write the answer as f of 0 is equal to 3. Now, if you were graphing later on, then 0, comma 3 is a point on your graph, but we will see that later. Now I'm going to follow the same steps to complete the rest of the questions. So f of negative 1. So again, I'm going to pay special attention to how I substitute. I want to make sure that I keep the parentheses. Now here order of operations has to be applied properly. You have to do the exponent before you can multiply the negative. So negative 1 squared becomes positive 1. Positive 1 times the negative is negative 1. 2 times negative 1 is negative 2, and all of this cancels out to give you 0. So f of negative 1 is 0. So if you know what this point will be on the graph, negative 1 comma 0 is on the graph of this function, and you know that whenever you have a point where the y value is 0, that point lies on the x-axis. So this in fact is a 0 of the function. This value of negative 1 is a 0 of the function, or the x-intercept of the function. So the next one is f of 3. Again, do the same thing, substitute and simplify. Negative 3 squared. So 3 squared is 9. Negative times 9 is negative 9. 2 times 3 is 6. And this is also 0. So f of 3 is also 0. So what does that mean? This function has another x-intercept at x equals 3. That takes me to f of negative x. So if I'm calculating f of negative x, I do the same thing. I go to my original function, which is negative x squared plus 2x plus 3. And wherever I see an x there, I replace it with negative x. And then I simplify negative x the whole squared. When you square a negative, it becomes positive. So I'm going to write one extra step just so that you can see it. So now this becomes x squared. 2, I'm going to keep this as is for now, just so that you see this. Then I distribute, so I get negative x squared minus 2x plus 3, and that is f of negative x. In the next one, I'm asked to find negative f of x. So when I have the negative on the outside, it means that the entire expression that denotes that function is going to be negated, meaning the negative is going on the outside. So now I had to distribute the negative sign. Negative times a negative makes a positive, negative, and negative. So this is negative f of x. As you can very well see, f of negative x is not equal to negative f of x in this situation. That takes me to the next one, which is f of a plus 1. So f of a plus 1. So again, wherever I see x, I'm going to replace it with a plus 1. Right? And then I'm just going to expand this expression. That's it. So here, one of the biggest mistakes that you might be tempted to commit is writing a plus 1 the whole squared as a squared plus 1. It is not. So when you do a plus 1 the whole squared, you have to multiply a plus 1 times a plus 1. So you could FOIL it out separately, or you can use the identity, which is a plus b the whole squared is nothing but a squared plus 2ab plus b squared. Now, knowing that, I'm going to keep the negative sign outside. I square the first term, a squared, plus 2 times a times 1, that is 2a, plus b squared. B is 1 in this case, 1 squared is 1. So then I keep this as is. Now in the next step, I'm going to distribute. So I have negative a squared minus 2a minus 1 plus 2a plus 2 plus 3. This and this gets cancelled away. Then I combine the like terms and I'm ending up with 4. So negative a squared plus 4 is my answer. Okay. And then in the last one, I'm asked to evaluate f of x plus h. So again, x plus h the whole squared plus 2 times x plus h plus 3. Now you know that x plus h the whole squared is nothing but x squared plus 2xh plus h squared plus this. Now distribute. You have negative x squared minus 2xh minus h squared plus 2x plus 2h plus 3. There are no like terms to combine here, so you can just leave the answer as is.